But so I'll give just yeah, no. And so Tartaglia was listening Niccolo Fontana, which is also our maths teacher. And Tartaglia was a mathematician who discovered the third grade equations. So what about Tartaglia? In the Tartaglia's triangle, which is also a way to simplify some equations, we have found Fibonacci series, which is a series which had for the first number, the number 1, the second number, also number 1, and then 1 plus 1 equal 2, 2 plus 1 equal 3, and so forth. So we have also found the triangular numbers, which are numbers we use for build or for draw some triangular. So for example, if we have a 36 units triangle, we can find 8, 7, 6 units, and then we build a triangle. And what about fractals? A fractal is a natural phenomenon or a mathematical set that exhibits a repeating pattern that displays at every scale. So in short, is a figure that repeats itself always smaller and smaller. What about fractals? Look at fractals. So look how maths is beautiful. It's quite good. So now I want 7 of you in these 3 chairs, and we have to find how many ways are there to sit in these 3 chairs. So come here, 7 of you, 7 volunteers. So you can always choose your seat. Yes, of course. Now another 4 person. So here. Please, it's okay. Here. 2, 4, 6, and 7. Oh, fantastic! So this is a combination. So try another one. Okay, here. Change your seat. So these are 2 combinations. We can find 35 combinations to sit in these 3 chairs, and I'll explain you why. So come here. And then we have the first number of the Tartaglia's triangle, which is 1, and we have to count 0, 1, 2, 3, 4, 6, 7, until we find this line.
Okay, sorry, can you sit there and we show everything to you? Okay, thank you.
Thank you.
Thank you. Fantastic.
So we have to count 0, 1, 2, 3, 4, 5, 6, 7, and then the number of the chairs 0, 1, 2, 3. So 35 ways to sit in 3 chairs. Thank you.
Okay, hello guys. Now we'll show you the best way in order to understand the properties of the Tartaglia's triangle. So we have made this program to show you these properties. Is there any one of you that will try to use this program? One or two of you?
Just one.
One. Only one. Okay. Okay. If we put a number in these boxes, the picture will show us the multiples of this number highlighted in the triangle. So, exactly.
Okay.
Okay, so
No, ecco. So you can see the multiples of 8 highlighted in yellow in this triangle. If you want, you can choose another two numbers. Another one. So I say you can see the picture will show you the multiples of these numbers. These triangles are called fractals, as Silvia said before. Now another properties of the Tartaglia triangle is that we can find the numbers of the Fibonacci series. So the highlighted boxes in the triangle are the you can go back if you want.
Thank you.
By following the highlighted boxes in the triangle, we can find the numbers of the Fibonacci series. So, for example, the first cell is the first diagonal, so is the number 1, the another number 1. Then, if we follow the green diagonal, we have 1 plus 1, that is 2, and so forth. We have the Fibonacci series, so 2 plus 1, 1 plus 3 plus 1, and so forth.
Okay. As you saw before, with the Tartaglia triangle, we can find some additions. So if you scroll down diagonally, you can make the addition by choosing any numbers diagonally, and the result of this sum will be in the bottom left box of the last one number you choose, or if you scroll on right, or if you scroll on left, will be on the bottom right box. Okay, this is the Eratosthenes heap. Also called Rita Bella, you can see there. So this works as a filter. It's used to find the prime numbers. In this here we have the numbers from 1 to 400, and if you write down numbers in these boxes, the first number is the first prime number is number 2. The program will eliminate all the multiples of 2, and if you continue doing this with the next prime numbers, the program will also eliminate these multiples, and reaching the number 23, there will be no more multiples of these numbers. So all the numbers that are not eliminated will be prime numbers for sure.
Hello everyone, now we are going to talk about music, art and colors. Hope you like it.
So, what are the primary colors? I'm sure that you know them. They are red, blue and yellow. Johannes Hilton discovered that you can get 3 secondary colors by matching the primary colors. These secondary colors are green, violet and orange. Moreover, each of these secondary colors has 4 shades. There is also an analogy between this chromatic disc and the sharp major scale. In fact, there are 12 elements in both. If the light passes through a triangular prism, it breaks light up into the colors of the rainbow.
During these experiments on the dispersion of light in a triangular prism, Newton noticed that there was an analogy between the 7 notes of the major scale and the 7 colors of the spectrum. You can also notice that there is a correspondence among the ratios of the intervals from one note to its following one and colors. For example, as you can see, between C and D, the color is red because of the frequency. You noticed this painting? Do you know it?
Yeah.
Here, this is the Starry Night by Van Gogh. Van Gogh painted this in the saddest moment of his life. As you can see, the sky whirlpools look like fluid turbulence. He also had an insight into the link between the star colors and their own heat. For example, as you can see, the red ones are the coolest, while the blue ones are the hottest. Thank you.
This is a work by a pupil of Johannes Itten. All these rectangles are golden rectangles. It means that the ratio of the inside lengths are in the golden ratio that is this. Thank you.
Hi everybody. Now we're going to speak about energy. Our aim is to produce clean energy starting from the sun, in our case from a lamp. The lamp, as the sun, issues photons, the elementary particles of the light, that are captured by the photovoltaic cell, composed by silicon. As everybody knows, why silicon? Why silicon? As you obviously know, silicon is a semiconductor whose electrical conductivity increases with the increase of energy that you feed into. So, however, photon serves to make electrons free to pass from the valence band, the mass outside part of the atom, to the conduction band and create electricity. This electricity serves to break down the distillate water into oxygen and hydrogen, and these gases are collected into what? Oh, thank you. Okay, in two separate gas storage tanks where oxygen come out. Then hydrogen reacts with the atmospheric oxygen in the fuel cell. Thank you.
So, as we said, the hydrogen are in the second cell, the fuel cell. The fuel cell is consists of an anode, a cathode, and an electrolyte. Do you know what they are? I'll tell you for you. The anode is the place where oxidation, and also electrons, takes place. The electrolyte substance that conducts changed ions from one electrode to the other. The cathode is the place where reduction, a gain of electrons, takes place. Two chemical reactions occur in these three places. The result of the two reactions is that fuel is consumed, water is produced, and an electric current is created, which can be used to power electrical vehicles, normally called load, which in our case is a fan, as you can see. At the anode, the catalyst oxidates the hydrogen, turning the fuel into a positively charged ion and a negatively charged electron. This is how the machine works. Okay, this is the fuel cell. The anode, this is the anode. A catalyst oxides hydrogen, turning the fuel into positive ions, change the electrolyte, and negative electrons. The electrolyte is a substance specifically designed so ions can pass through it and arrive to the cathode, but the electrons cannot. The freed electrons have to travel through a wire, creating a current electric. This is the wire. Once reaching the cathode, the electrons and the ions reacts with the oxygen to create water and energy. To let the oxygen get in, we open this cap. as seen before. Individual fuel cell produce relatively small electrical potential, about 0.7 volts. So cells are stacked or placed in a series to increase the efficiency of a fuel cell. In addition to electricity, fuel cell produce water and heat. The energy efficiency of the fuel cell is generally between 40 and 60%. The fuel cell finds application in cars. In fact, the motorists are trying to replace the engine that use gasoline or diesel with this type of engine. In a wells-to-wells simulation analysis, General Motors, you know General Motors, the famous motorist, and its partners estimate that a fuel cell electric vehicle running with hydrogen atmospherical will pollute about 50% less because the only waste product is water. This is the cap that we have to open to let the oxygen come in. Thank you.
Hi guys, I'm Marco.
My name is Giulia. We are students of the third year. We worked on light and natural pigments in food, and now we are going to explain you our project.
As you may already know, white light is not really white, but it is the set of all the radiations in the light spectrum. For example, when light hits a red-colored object, the object absorbs all the radiation different from red and reflects only color which we see, which is red in this case. This happens in the food with the help of natural pigments.
Lycopene is the pigment of red color and belongs to the families of carotenoids. It is present in strawberries, apples and watermelons and inside every red fruit. It is very important for our body because it protects it from the harmful effect of light and oxygen.
The carotene, this picture you can see in the picture, is also a pigment which is contained in yellow and orange fruits. It has an important role because it synthesizes important vitamins such as beta-carotene and alpha-carotene. We can find it in every orange or yellow fruit like oranges, carrots and lemons.
Chlorophyll is the green pigment which is in the leaves of the plants. Without this pigment, life on Earth could not exist, because thanks to chlorophyll, because thanks to this pigment, plants are able to produce oxygen with a chemical reaction, and we all know that without it we would not survive.
Anthocyanins are the most important pigments, and they are present in blue-purple colors. They are the most important because they act as antioxidants and fight the aging body by destroying free radicals, which are very dangerous for us. They are contained in eggplants, blueberries, and in every purple food. They are very important and...
Finally, allicin is the white pigment. It is mainly present in garlic and fennel. It lowers blood pressure and reduces the risk of stomach cancer and cardiovascular problems. Thank you.
We want to conclude, and we also want to say that some students of our school have won Olympic Games in maths and physics, such as, for example, our classmates and other person of the school. And that's all. Thank you, and bye.